Hi guys, I hope you're having a good Corona break. Today we're going to be going over section 10.1 for geometry. In this section we're going to learn about areas of shapes that we've already dealt with in the class before. This over here is the formulas to know. I would start writing your own formula sheet. Refer to it whenever you're working on your homework. The first area formula found on page 677 is the area for parallelogram. It is simply the base times the height. The next formula is the area of a triangle. It's found on page 678. It's equal to 1/2 the base times the height. The area of a trapezoid found on the same page is 1/2 times base 1, which would be the bottom or the top, and base 2, which would be the other one. Notice a trapezoid has 2 bases. Anyway, that's also multiplied by the height. The area for a rhombus or a kite can be found by multiplying 1/2 times the diagonal times the other diagonal. Okay? Keep in mind, parallelograms include rhombuses, but also rectangles and squares. So this formula can be applied to both of them as well. In the case of a square, all the sides are the same. Same for a rhombus. So the area will essentially be base squared, or more commonly seen in math, s squared. Some other important things to know. Base is symbolized by the letter B, H is symbolized by the letter H, and a diagonal is symbolized by the letter D. The base of a triangle will always be the longest side of the triangle. Alright? Diagonals they connect to non-adjacent vertices. Remember, we talked about how a vertice was the point that 2 lines connected at. The non-adjacent point in this parallelogram would be the one on its opposite side. So the diagonal would be a line going from here to here. Okay? This is a review from chapter 6. Furthermore, your answers will always have the distance unit squared. Some examples of this are centimeters squared, meters squared, inches squared, feet squared, miles squared, and so on. This happens because when you multiply the dimensions together, the units count essentially as a variable. Okay, one final thing, whenever you're doing all these area calculations, make sure before you plug it into your calculator and do the operations that everything has the same units. You won't get the right answer if you multiply feet by miles. Okay? So here are some examples that I took from the book, as well as one that I made up. You have your worksheet, so these will not be part of the worksheet. You're more than welcome to work in the book to gain a better understanding of the material. So the simplest thing that we'll do in this section is simply plugging numbers into the formula. The area of a parallelogram, if you notice, it's base times height. Our height right here, our base right here. We multiply the base times height, 10 times 12 for 120 centimeters cubed. This next problem's a little trickier. Instead of finding the area, we have to find one of the other variables. Don't panic, it's still really easy. We plug the numbers into the formula and do one step of algebra. Okay? We know the area of a rectangle, it's a parallelogram, so it would be base times height. Our base is 2x. So, we plug our numbers in. The area is 10x squared, and that's equal to 2x times the height. We divide each side by the coefficient, or 2, to solve for the height, and we end up with a height of 5x. Okay? Problem number 3 is even a little bit more difficult. It expects us to have a certain understanding of squares and perimeters. Remember, the perimeter is the sum of all of the sides of a figure. So the perimeter of a square would be s plus s plus s plus s, or 4s. We went over the area of a square. Square is s squared, where s stands for a side. You can use the letter b or h if you want to. It's just more commonly referred to in math as s for squares, because squares start with s. So mathematicians are lazy. Anyway, for this problem, we start by solving for our side. We use the formula, the area of a square is equal to the side squared. We plug in our numbers. 169, which was the given area of the square, is equal to s squared. we take the square root. It has this radical symbol on your calculator. Generally, you will press the second key and then the squared key. That will get you to this radical symbol. Okay? Pretty cool, right? Radical. Anyway, the square root of 169 is 13. That's our side. We then plug the side into the perimeter formula. Remember, the perimeter of a square is 4s. So, we do 4 times s, 4 times 13, and get a side of 52. Okay? So that's the basic steps. I wanted to go over a trapezoid because it looks the scariest of all those formulas. Don't panic, there's just one more variable. Okay? Right here, our bases are the two parallel sides of the trapezoid. Here they are 8 and 20. Our area is 280 centimeters squared. We start with writing our formula. Then we plug all of our numbers into the formula. So we get 280 centimeters squared is equal to 1/2 8 plus 20 times h. We simplify this. 1/2 times the quantity 8 plus 20 will give us 14. Now we divide each side by 14 and we get 20 centimeters is equal to h. Fairly straightforward. You guys have got this. You've done way harder math. Okay? I want to go over two more things quickly. You're going to be asked to find the area of more complex shapes. To do that, you need to draw imaginary lines separating the shapes into shapes that are simpler and you are more familiar with. For example, right here we have a pentagon that looks kind of like a house. We can separate it into a square and a triangle. The side of the square is 8, therefore the area is 8 squared, or 64. The area of a triangle, 1/2 base times height. The height of our triangle is the side of the square. So we get 1/2 times 8 times 4, which will give us 16. To get the area of this pentagon, we add 64 plus 16, or 80. Finally, if you're trying to find the area of a shape that has space removed from it, instead of adding the areas together, you will subtract them. I hope you guys are having a great time. Please message me if you have questions. I look forward to hearing from you.